Okay. We have some time to kill at the start. I'm just waiting for a part that will allow me to connect the mic to here, which Bethy's gone to grab. But we might as well, we'll wait till 5 past to properly start lectures. But are there any questions I can answer about the project or uncertainties that people have that we can talk about? Yes, Peter. Does anyone have a formulated question they want to ask? Yes. That's a great question. I don't know. So it's an S3 bucket, which is in the AWS environment. Now, Alan, who's one of the tutors and runs the research part of this system, he said he was going to build a service which you can call as an API to import data into that S3 bucket. I don't know if he's done that yet, so that might be a great candidate for a team project. Someone wants to build an import service that just takes data that other teams have gotten from external sources and puts it into the S3. If you want to get in before Alan does on that one. There's that. What was the other part of it? You might be able just to interact with the S3 directly. I would recommend having a layer of abstraction there. So yeah, maybe if one team wants to build that import service and then other teams can use that import service to put data in the S3, then you'll get a whole lot of points, right? Because you've got literally every other team using your API. Yes, I hope that answers your question. Sorry, here's another one.
Does that mean that we should be building our own database for our own data? Does that mean we should I thought the idea would be we wanted a certain type of data.
Yep.
And we store that data for ourselves as well that other people can access right here.
You can store stuff in your service if you want, but the end state is that it should end up in the S3 because your little database on your microservice, it's not super scalable. It's you might want to do some I don't know, whatever your API does, you might want some persistence for that. But ultimately, if you're building, actually, I'll go back to the spec. It's kind of the architecture that we talked about last week, where you have sort of one center of data and then the other applications are built around that, less so than each microservice has its, it might have its own database, but the center of data is this lake here in our system. And so you get some services who are accessing the data store. So a lot of you can be doing that. Some services, I was just talking about, whose job it is just to take data and put it in the S3, and then other services who will take it out of the S3. Other services will transform it. So this data lake is the center of the application in that sense, but you might want to have your own database to do some of your own stuff. Does that roughly make sense? Cool. Sorry, did I answer your question up the back? Yeah, cool. Yeah.
Just a clarification on the spec. Engineering. From memory, it said that you had to talk about the value of the ecosystem.
Yep.
That sounds to me where the engineering proposal would justify why we're adding. But I think from tutorial, it sounds like it's more justifying the end product that we want. But that's a bit different.
No, I would correct what was said in your tutorial. It's the service you're building. It's this thing you're building for Sprint 1. Yeah, because that'll have business value, right? It will in some way correlate to the broader ecosystem. Maybe you're building an import service. Someone the other day was one of the mentors said to me, "Oh, can this group use this Transport New South Wales or some public transport API?" And it's then you're adding value to the business in some way by building this microservice.
So in the engineering proposal, do we have to we're talking about the business value of our final product at the end, or the business value of that one microservice that we're doing currently?
The one microservice you're doing currently, because that is a.
Really need to talk about the bigger picture.
No, but I wouldn't think of it in that way, because the stuff you're going to be doing, it's not kind of like in SENG2 when you did the e-invoicing stuff. It was you built your back end and then you built the front end and you make your full stack as a single product, right? That's not really what we're doing here, in the sense that your API could just exist and then the front end that you or the interface you build in Sprint 3 has nothing to do with what you did in Sprint 1, right? The point of that, and we'll cross the bridge when we get to it, but that's just orchestration. Right now is you're a back end microservice team, and that in itself will be a finished, maybe not a product, but it's going to be a platform, right? This is our platform as a service stuff where you're building APIs which other services can use to leverage off and build their own software. Maybe front ends, maybe like, you know, your API will be used by some other team in Sprint 3. Maybe it'll be used by you. Who knows? Yeah.
Actually, an API, like for example, if you're doing the import services,
Yeah.
it's taking data you will be into the group.
Yeah.
The CSV file.
Mm-hmm.
And straight dumping into that.
Yep.
If there isn't any communication required beyond the way.
Like it's I use the word API in a very, very loose sense, in the sense that like you feed it some input, it works as a black box, and it has some side effects like imperative programming, or it produces some output. Like everything is an API in that sense.
So like that just would be like a GraphQL thing for other users to connect to.
Depends. It depends on, like, maybe this import service is a public facing API, so you want to build it. We'll talk about that today. But you build it in GraphQL so that you can. Files are a bit harder. Actually. I don't know how you do files in GraphQL. You might want to use REST for that one. Yeah, like you give it a CSV file, or you give it some sort of. You could do it in GraphQL. Is what I'm saying. Thank you. Now I hope all the online people are here, because I realized that this was like a single meeting link. It's not allowing you to register for the event. Oh no. Oh dear. Okay. Let me fix this. I'm just going to start a new Teams. I'm trying to join. Okay. Let me fix this. Calendar. Edit series. Goes every Thursday. See, this is what I wanted. Okay. Okay. No, I don't want that. Okay, let's just manage event. Okay, yep. Save. Okay, can the online people hear us? Please give us a hoy in chat. Now that I've got the microphone working. We've got here in chat. That would be great. Okay. Raymond typing works now. Awesome. Let's get on with it. Okay. Any other questions? Some really good questions here from. No? Okay. I have some housekeeping. Reasonable amount to cover today, so I forgot to talk last week about the portfolio and about the expectations, and I was so excited to talk about it, and then I just got distracted by all the microservices and stuff. So same as SENG2 last year, you need to do a portfolio. There'll be a draft of that due in week 5, which will just be a peer review, so that won't be marked, but you'll get to assess each other's portfolios and give feedback. That'll help you for the final submission, which is in week 10. It's important that you do your weekly blog, and some people have done their week 1 blog about 55. Okay, that's more than last night when it was 2. That's only like a third of the course, so 2/3 of the course have just missed out on basically free marks for putting up your week 1 blog. That's the blogging overall is 35% of the portfolio assignment, portfolio assessment. So please do it. Please post your blog up so that you can comment on other people's blogs and they can comment on yours. Same as how it worked last year in SENG2, which you're familiar with. Other one, oh, sorry, are there any questions on the blogging of the portfolio? Yes. I'll try, like the infographic, I'll try and make it less based around that because that's what my gripe. So that last year was like, it was too much to just like make this aesthetically pleasing, and that's like a big percentage of the mark. Yeah, we'll figure that out. The problem is it's like, it's got to be visually appealing to your marker, right? Like it can't just be this big wall of text, which is really hard to assess. Yeah. Not really. You'd like, I think for this week, I was just like, everything came out a bit late, so you could just do it a few days late. But ideally, try and get it done by the Sunday. That shows good time management for one, because that's one of the things you'll be demonstrating as part of your portfolio. And it also means that you're not getting like behind on blog posts, which was a big thing last year that I saw, where people would just be like, it'd be Wednesday of the following week, and you'd still be putting up your blog from the last week, and it just kind of piles up. So all self-guided in that sense, but makes it easy for you. Yep. Cool. The only other thing, I wanted to do this thing on expectations, and you can actually edit this Confluence page, and a big thank you to everyone who's put up expectations of you and each other, which you can read, and your expectations of us, which I think is really cool, because we have things like my experience and course feedback, but it's all delayed and it's all later. When we talk about influencing behavior in week 5, I'll explain why this is a big thing. But it's nice just to have like a conversation at the start about like what you expect and what we expect, and see where we can align. So I was reading this, and like clarity, that's a big thing. I think we talked about this last week a little bit about like part of the ambiguity and the open-endedness of the project is the project itself. Like that's what we're trying to achieve in this course. So try to have less ambiguity. Please, if you've got questions, we'll answer them. Please, like if we say it's up to you, or you can figure this out, or basically give you a non-answer, please don't be offended by that. It's not because we're lazy, it's because the point of this course is that you learn how to teach yourselves, and I think most of you appreciate that.
It's also about community, because in a workplace, not you and the management, modern workplaces with a very inclusive manager wants to like this dialogue. So somehow, as we try to do the same, we think it's a good idea to do this way. Maybe use as much as possible. We want to give us ideas to, and we are flexible, because ultimately this is a very qualitative. Come out of it learning new stuff. You come out of it better at communicating ideas. It's our course where you fix deliverables. That's the tick. I think that's something we want. When you talk to your mentor, feel free to express some opinions. The mentors will always feed things back to us. Feel free to talk to us directly. In some cases, there will be some expertise test, and we much with. Again, that open-endedness is scary, but at the same time, the best preparation you can have.
Make the marking fair. Unfair contribution, also an issue. I wish there was a way to catch those who don't contribute much. Yeah, there absolutely is a way. By talking to, like, the two things I always say is, firstly, talk to them. I see a lot of groups where they kind of just haven't had a conversation, and it's a very, very tough conversation to have, don't get me wrong, where you're like to someone, you haven't done any work for the past week, or I need you to do something. That's difficult. That's all part of the process, and that's a big part of why we want this to be in your portfolio, where you say, maybe I had this difficult conversation in week 3 with my teammate because they weren't pulling their weight. That's all part of the process, and we want you to go through that. And then the other thing is obviously talking to your mentor, like you would in industry. If you've got a problem with someone in your team, you talk to your manager. It's not, this sort of world of first year where you have like a peer review form at the end of the project when everyone's gone, and you sort of anonymously rat out, the people that annoyed you in the term. Because that's again too late, too delayed. Nothing. We can't really do anything, and you guys can't really solve the problem yourselves at that point. Cool. Guidance. Yep, will definitely help you when you're feeling lost. So I just wanted to go through that. I think it's a good exercise, and we'll try and do that in future terms as well. Let's get into today's content, which is, we have 3 topics. I hope you enjoyed Hayden's lecture on risk on Tuesday. I thought it was pretty interesting, very security focused. Did anyone who watched it? A few people, okay, watch the recording, worth doing. And then the other pre-recorded lecture was on containerization. That will help you for building Docker images. And Docker is one of those things that people go, oh, I wish they taught this in uni. So now we're doing it. Let's get into the next one though, which is managing dependencies. This is kind of like not a super content heavy topic, but just generally important to know and generally important to think about when we're building software. I think it used to be part of 1531 and then they cut it out just because there wasn't space. So let's talk about it here. We're going to talk about what software dependencies are, and you've all used libraries, you've all used packages, no matter what programming language you work in, all software is built on abstractions, right? You build abstractions on abstractions on abstractions, whether that's APIs, functions, classes, packages, however you want to call it. We're going to talk about some issues in managing dependencies and some trade-offs when it comes to different non-functional requirements and how kind of we sometimes sacrifice writing good software for writing reusable software. Okay, so everyone has, what's an example of a software library that anyone's used in any language? Pandas in Python. Yeah, what's another one? Yeah, just like standard libraries that you'd import. Any other ones? Math, yep. PyTorch. Any other languages? Yeah, yes. Stdio and stdlib and stuff in C. Oh, you've spoiled my story. Okay, we're going to talk about that actually. Okay, so we use software libraries all the time, and software libraries are platform as a service, right? We talk about how platform as a service comes in many different forms. We looked at containers earlier in the week. This is a software library is a platform that you can use to help build your software. So the questions you need to ask, you say, well, when I say, okay, I'm going to use PyTorch in my piece of software in my library, in my API. The questions you need to ask are, what does that actually mean? When you say, I'm going to import this thing and I put it in my pip file or my package.json or whatever your dependency package manager is, that means we suddenly have this dependency. And you can think of a dependency as being like a crutch, right? Like someone who's on crutches, if you're a horrible person and go and whack out the crutches from underneath them, they're gonna have a bad time. So we're depending on the fact that the author doesn't suddenly remove the library, right? Like, because if they take the library out, then your software is cooked, right? You've just whacked out the crutch from underneath them. What if they do something like they make an update to that library and then that causes your software to break? What if the author's malicious and your PyTorch library is actually a piece of malware that will infect your computer when you import it? And then maybe your software's library is okay, but what about that library's dependencies, right? Because that library, again, it's all abstractions on abstractions on abstractions. That library will rely on other libraries to, much of the time, build its own software. So this leads us into the 2 different types of dependencies we have. One is called direct and one is called transitive. Your direct dependencies are the things that are in your pip file, your package.json, your requirements.txt. They are the things that you have imported into your code. Transitive dependencies are, again, the libraries that your dependencies rely on. They're the dependencies of your dependencies. What that kind of means is that when we start to map out our software and all its dependencies, we get a certain kind of data structure. Does anyone know what that might look like? Think recursion. Graph or sorry? Not in that sense, no. a graph or a tree, right? Like, and we talk about dependency trees and dependency graphs. So this is a visualization. I think it's a Python one, where we've just gotten some sort of package or some sort of, someone's API and said, okay, map out all of the dependencies, both direct and transitive, of that piece of software. And you can see it's this massive web, right? Like your software maybe imports 6 libraries, and those 6 libraries each import 6 libraries. That's 36 dependencies, and that's just scratching the surface. So most of this is handled for you by your package manager, and you don't have to worry about it too much, but it's important to know and important to understand, because sometimes things go wrong. Now, when you're making dependencies, you say, okay, I'm going to import this library and I'm going to import this other library. Sometimes we run into 2 different sort of problems, and the first of those is diamond dependencies. So let's say you've got an application called SumApp that relies on mycoollib and otherlib, and though they both rely on versions of PyJWT, we'll talk about versioning in a second, but they, you say, I want to work with this particular version of the software or this particular version of the library so that I can guarantee that those functions will always be consistent and the package won't just break on me. But then these 2 libraries both specify a different version of PyJWT. So when you're building your dependency tree and compiling your project, this will come up as a problem, right? Because it'll say, well, I need to download PyJWT, but these 2 versions are incompatible. Now, most of the time, your package manager will resolve this itself through a process called dependency resolution, where it essentially just does a graph solve, like a graph algorithm to solve all of the dependencies and find stuff that matches. Every so often you'll get these things where you as a programmer have to manually intervene and go, depends on the language you're working in. So sometimes like this just might be impossible. I think in Python it might be the case where you actually just have to say, well, I have to not use otherlib, or I have to use some different version of otherlib that doesn't have this dependency. Other languages like Go, you can do this cool thing where you say, well, I'm going to have this, maybe I'll use 1.7.1 so that I can use mycoollib, and then I'm going to replace that with 1.6.4 for otherlib. So you can do things where you swap around dependencies. These sorts of diamonds, though, these problems come up a lot. Then the second type of issue is a circular dependency. This is less true in like a case where you're importing other people's libraries, because generally it will form more of a tree. But sometimes you get these cyclic graphs, right, where package A relies on B, B relies on C, and C relies on A. Most commonly, I've seen that in when you build your own software and you accidentally have, here's this package which relies on this function in this package, which relies on this function in this other package, and then it all forms a big circle. And most compilers like Java, in particular, because that's very package oriented, will pick that up and say, hey, there's this circular dependency, because you need to wait for one package to compile before another one can compile, then it'll detect that cycle. Okay, a lock file. So when you specify your dependencies in a requirements.txt, package.json, you often might see this thing like pipfile.lock or yarn.lock or something, some sort of lock file. And what that does is when your dependency manager goes in and solves the graph problem, because sometimes, like maybe if you go back to here, it might be less strict than this. So your dependencies say, well, I need a version of mycoollib which is less than or equal to 1.7.1 and greater than or equal to 1.6.4. Right, and there's some overlap there between the 2. So it'll find a version of PyJWT that satisfies both of those constraints. And what it does is it stores that in the pipfile.lock or the lock file. And that what it does is says, okay, here's the exact version of the library that's being used that works with all the other dependencies. And then you can commit and push that, and someone else clones your repo, right? Just like the container stuff we talked about earlier, where someone else can produce the exact same version of the code, they use the exact same libraries. So in this case, it's not a great example, but the fuzzy wuzzy library in Python, which I think just does like fuzzy string matching, we've said that any version, like a wildcard, will be matched. And then that's in the pip file. And then in the lock file, it says, here's the actual version that your software is using, 0.18.0. And then it also has a hash digest of the library. Does anyone know what the hashes are used for? Yes. Yep, it's a security risk. Does anyone know the specifics on what the hash gets used for? It's similar to how password hashing is done, yeah. So when you say here's the hash of the library, and then someone else clones the repo, and then they run yarn install or pip install, and they download all the dependencies. And as they download, they check the hash of the downloaded library, and they check that the hash matches the hash in the lock file, right? Because the hash of the same thing will always be the same, right? That's the point of a hash. So that's just a process of maintaining integrity. Cool. Semantic versioning. So we touched on this. A way to deal with dependency management problems is to version software. And that's just a general thing, right? It's not just true of libraries, it's true of APIs. People will rely on your software to behave a certain way. And when things break, that's not generally very good. So we say, okay, well, maybe we keep the old version active and then we have a new version and we just say, /v2, for example. The way that's done sort of semantically is you have major, minor, and patch. And if any of you play computer games, you might have seen this all like, with Windows, when they say we're going to release Windows 7, Windows 8. They're major changes. And that breaks the API contract or breaks the Liskov substitution principle in the sense that you're releasing a new version of the software which someone can't just substitute for the old version. Very quick recap. Who knows what LSP is and stands for? Yeah, Luke? Yes, you should be able to, all subtypes should be substitutable by their base type. So what that means is, in this context, is that if you've got an old library and a new library, if you maintain LSP, you should be able to use the new library in the exact same way that you use the old library. And maybe it strengthens the post conditions and weakens the preconditions, but you can use it in the same way and nothing will be affected. I could go on a long explanation of what LSP is, but I would just revise that. In this context, it basically means that your ticket doesn't suddenly change the terms and conditions on you when you're using that software library. So major means breaking changes, minor means non-breaking changes, or what we call backwards compatible changes. So we maintain LSP. And then a patch is just like a bug fix that's backwards compatible. Now, some people argue that bugs or bug fixes aren't backwards compatible because by the nature of the change, you are changing the behavior of the API. And there's this really interesting thing called Hiram's law. Has anyone heard of it? Yeah.
Like, I don't know what your says and what your guy says.
Yep.
If there's a bug, then currently need to real world actual
Yeah, spot on. It's basically just that. It's all no matter how big your contract is or what is in your actual documentation, all observable behaviors of your API will be depended on by someone, given you have enough users. I saw this a lot at Atlassian working on Jira, because Jira has heaps and heaps of users, and it's really hard to make changes because you say, well, this maybe this particular feature, we'll say like it's hard for them to rebuild the system because they say, well, there's all these bugs that customers rely on in the software, so we can't just rebuild it because then we can't reproduce those bugs. Really interesting thing. So in that sense, a patch fixes a bug, but it will change behavior. Sometimes you have to manage that with what's called change boarding with your customers. Okay. A little copying is better than a little dependency. Who agrees with this statement? Who disagrees with this statement? Who's not sure? Okay, that's all right. I'll give you 30 seconds, turn to the person next to you, talk about it. Is a little copying better than a little dependency? Any questions in the chat? Oops. All right, cool. Let's call it there. Having discussed it now, who thinks yes, a little copying is better than a little dependency? A few more people. Who thinks no? Cool. This is one of those open statements. Rob Pike, which I think he spoke to you guys last year. He chatted to the SENG3011 students last week. He's one of the creators of the Go programming language. Super cool language. I love Go. And this is one of the Go proverbs, which is like a, like the sort of agile, it's like a manifesto of what Go is all about. And this is one of the things that they say, which is that a little copying is better than a little dependency. And as programmers, and we're at fault as well as, teachers for doing this, because we always say, don't repeat yourself, right? Dry, make sure you abstract, make sure you put this in a helper function. You should never have 2 lines of code that do the exact same thing or look the exact same. And we're obsessed with this idea of reusability. We're certainly obsessed in this in the sense that, we build all these abstractions. That's what I was saying before of we build platforms on, platforms and everything's just a bunch of abstractions laid on top of one another. That has 2 problems. The first is kind of the stuff we talked about last week when we talked about microservices, right? Where it's the Moodle problem where you try to build a software that satisfies everyone's use cases and then it satisfies no one's use cases. You can kind of apply the same thinking to like any level of programming. That's the first one. The second one is this problem of dependency where, now we've added this extra thing that we rely on that might go wrong and presents to us risk, right? And we talked about risk on Tuesday. And dependencies are a huge risk for companies, including this example here, which, what was your name? Which Will has already told us about, and that is Leftpad. Does anyone know, other than Will, what the story is about? Okay, so NPM, or Node Package Manager, right? It's the predominant framework that people use to manage JavaScript projects. You go into NPM, there's millions and millions of libraries that are made by random programmers from all over the world. They can just put them up there. And people can download them and use them in their projects. And you specify it in your package.json, and then you run npm install, and it downloads the dependencies. One such library was this one here called Leftpad. And this is the entire software library. It's one function. It has 11 lines of code. And guess what it does? It's kind of hard to guess what it does just by looking at it. Yeah? Yeah, literally. It gets a string, and then so you've got string len, which is the number of spaces to pad by, and then I think ch is the character to pad by, which defaults to a space. But it just says pad this character by this number of spaces on the left. That's all it does, right? Like you could do that in Python in less than 1 line. And so what happened was this was out there on npm, and then the author removed the library, and then a whole lot of software broke. There was this huge thing, and people got really annoyed about it, which is kind of understandable. Now, you kind of think that's weird. Okay, why would a whole lot of software break just because one npm library went down? Anyone else? Yes.
Well, other packages that
Yes, exactly. It wasn't. I've built my my SENG3011. I've built my CSE front end. I haven't myself used Leftpad, but maybe I've used a library which has used Leftpad, or somewhere in the dependency tree or graph, someone's used Leftpad. And so if that goes down, the whole thing goes down, right? Similar example. I don't know if I'll tell you the example, but not related to coding, but a bunch of people they got done for plagiarism in ethics last term. The reason they got done for plagiarism was because even though they all used different sources, a lot of those sources were, I think, there was some connection to a single video, and the video had been plagiarized from this article, and all the stuff in the article was wrong. So all the stuff in these people's essays that they were saying was wrong. And it all came up and turned it in as being highlighted as plagiarism, even though they hadn't necessarily plagiarized the same direct sources. So it's again the same idea. What's the problem here though, right? In this case of Leftpad. Yeah. Yeah. It still has 2 million weekly downloads.
Yes, like this week it was 1.8, but
That's nuts. That's nuts. We're just going in circles. Yeah, look. Exactly. So this is probably a case then, maybe like 11 lines of code copied, not going to kill you. Bad dependency that NPM someone takes down, that's going to, I mean, it doesn't kill you, right? But it'll cause problems, as it did. I think this was back in 2011. That's crazy that it's still got several million downloads a week. Sorry? Yeah. Broke React, broke heaps and heaps of JavaScript projects. And this just comes down to like someone at some point was just a bit lazy and was like, oh, or more interested in the idea of reusability than they were of maintaining good software. So it's a trade-off, right? Like you have to find the balance. So that's just mainly like a thing to think about. And when you're building your services for Sprint 1 and just beyond that generally, it's just think about like, is this library I'm importing, like, have I actually gone and researched and made sure it's a good library and not some malicious author? Have I made sure that, I actually need it? Having as few dependencies as possible is really good, because this is what we call a problem in software safety, right? Again, back to this idea of risk. This is where every dependency creates a risk. But we also have risks in software security. Who knows what a supply chain attack is? Up the back. Yeah, or just like not even software. Just what's the idea of attacking someone's supply chain? Yeah, exactly. Like you want to take down an army, right? An army runs on its stomach. You take out the food, then they're gone. It's the same thing in software, where like if you can bring down, as we just saw, a whole piece of software by attacking dependencies. Do people remember what, I think it was a couple of years ago now, Log4j? There was this big security vulnerability exposed in Log4j that hundreds of companies, because everyone uses big enterprise Java applications, they all relied on it, and their security teams were having a bit of a bad week. So there's a big emphasis at the moment on this. You want to keep your supply chain secure. Again, this goes all the way down, right? Your direct dependencies might be okay, but what about your transitive, your tertiary dependencies? GitHub and probably every source control piece of software by now provides what's called static analysis security testing. Basically, it just looks at your requirements.txt or your pip file or whatever and says, this library is outdated, or this library has a security vulnerability, or this library has a new version which you can upgrade to. And then it gives you a little, on GitHub it's called Dependabot, but it just basically tells you bump this version of the library. That's really useful because then you don't have to do it manually. Yes, question. Does it send an email every week? Maybe you should upgrade your libraries. Okay. Oh, right, I see. I have this one's from like a repo that I used to maintain. Every so often I get an email with some new thing that's come out, like this new library is deprecated and there's a better version available. So that's why keeping your software up to date is useful as well, and bumping versions. Any questions on managing dependencies? Nope. Cool. Yeah, sorry.
When you're in industry, and then kind of differentiation. Everything on. How do you choose?
That's a great question. I personally don't really know. I've never been through any process that's like vetting of dependencies. I'm sure most I'm sure most companies would have some sort of that either have some vague guidelines that people don't follow, or that have like a strict practice of here's if you're adding a new dependency to the list, then it goes through like a formal vetting process and gets reviewed by other people. But like whether it's in these projects or whether it's when you go to industry and stuff, it's like just have a bit of a Google and see if it looks legit. Like if the the library will be some public GitHub repo. If it hasn't been, there are no commits in the last 5 years, and there's like one contributor, you're like, okay, maybe this is a little bit dodge, right? So you can just kind of use your judgment there.
We had a guest pilot this second year, so talked about that. They have a separate team that.
Oh yeah, awesome.
I think there's one can just request goes.
Yep. Cool. There you go, Luke. Yep.
Does it happen often that actively
That's where sorry, the question for online people was, if you're constantly updating your dependencies, doesn't that cause problems? And that's where semantic versioning comes in really helpful, because you know that if you're building an API and you say, okay, I'm releasing a new version, and it is backwards compatible, then I'll release it as a minor version, so that I'm using your API and go, oh well, I can use that new version, and ideally it shouldn't break anything, right? Like there's risk to everything. Maybe stuff does break.
All these things are integrated.
Yep. Yeah, that's actually a really good point. Like where a bunch of tickets I've worked on in industry are just like, go bump this version of this library, and it's a one-line code change. You just change the version in the requirements file, and then make sure that all the tests pass and go through your CI process. And that's actually another got me thinking about it. Is one of the trade-offs of microservices where you now have to manage all those dependencies across a bunch of different repos and not just in one place. So there's more points for things to go wrong, and certainly a lot more maintenance that you have to do to keep the lights on, is what it's called, KTLO. Good questions. Any other ones? Yes. That's a good question. It depends. It depends what you're doing. Like I wouldn't say, like if you're, I'll give you an example. So you're Netflix, right? Like we talked about last week. Massive company, going to want to go microservices for all the reasons that we talked about. I'm working on rebuilding the thesis management system for my thesis. And so at the moment, I'm in this process of going like, oh, well, I want to do microservices because I want to do some empirical software engineering and see how good microservices are. But it's also a case of like, is this domain big enough to justify microservices? Like it's not Netflix or Uber. We're just talking about UNSW's thesis system. So, and it's me and one other person, right? So it's just like maybe is it the right tool for the job? And it might be the case that we're like, well, we can't, like we talked about with the bounded context last week. If you can't split up your bounded context because you're like, there's only one context to the problem, then maybe like it wouldn't be a monolith in the sense that a monolith is this massive code and it's again one service to rule them all. But it'll just be a single repo, right? That's a good question.
On your own. So I have to.
Cool. Any more questions? Okay, let's crack on. Sorry, any questions from online? Okay. Next one, advanced data interchange. We might do a bit of this and then break and then finish off the rest.